This is a continuation. This is part 2 video. Let's go ahead and get cracking. You'll notice that I don't like how they put the negative in front. Okay, it may confuse some of you into thinking it is an amplitude. I would strongly suggest rewriting this as f of x equals cosine x minus pi over 6 and then minus a 2 on the outside. That'll help you recognize better that this is a k value, right? So if we have a would be 1, positive 1, right? There's nothing in front. There's a positive 1 right there. B would be a positive 1 as well. This is looking like a pretty simple problem so far. C is negative pi over 6. K would be negative 2. Remember, we'll leave the K until the end. Amplitude will be 1. Period will be, well, golly, 2 pi over 1. Okay. The horizontal shift, that will be negative C over B. So that's negative pi over 6 over positive 1. So the horizontal shift is simply pi over 6. Remember, this is your first point. And please notice that we've been doing every problem the same, right? You know, when we meet together in class, and we're going to do the same way as well, all right? So just be aware. It's pretty methodical. There really isn't too much thinking that goes into these at all. Just keeping track of little things. Let's look at the increments. This becomes a little fascinating. This is what you've been waiting for. Increments. So this is going to be the period divided by 4. Remember, I do this because the unit circle is made up of 4 quadrants. And what happens is that I'm going to divide that whole thing by 4. So I'm dividing the period by 4. The period in this case is 2 pi. If I reduce that, I get pi over 2. Now, it's those of you that are catching on to this pretty quickly, you're realizing that these are not the same. Okay. And this is the opposite of what we did before in the past. So my first point is pi over 6. That's true. But now the task is going to be to make this pi over 2 look like this pi over 6. So may I suggest that if we multiply the top and the bottom by 3, then we're going to get that. Remember how in the past I always put a 1 in front with parentheses? I think this makes some sense now. In this case, it's a 3 in front. So what I'm proposing to you is we're going to be counting up by 3s. We're going to count up by 3s. Okay? So in other words, if we were to add 3 to this, right, this is going to be 4 pi over 6. And then if I were to add another 3, it'd be 7 pi over 6. And then add another 3, it would be 10 pi over 6. And if I were to add another 3, it would be 13 pi over 6. Now remember, this is not for the faint of heart. I'm treating you like I would my college students. This is how I train them to graph. And I'd say, good golly, 90% of them get it like this. So I do expect a couple of you might be struggling with this idea. However, with my college students, I go through it pretty fast. With you guys, I'm breaking it up to many different sections. So please take your time to review, to collaborate with other people to try to understand this. Otherwise, stick around for office hours. Otherwise, if you want to resort to the book or Khan Academy or YouTube because you know better, that's fine with me. As long as you know how to graph, that's what I care about. Okay, and graph without a graphing. Now we're gonna go ahead and reduce these. Let me erase all these little positive 3s so we don't confuse ourselves. So this becomes, the first one becomes pi over 6. The second one becomes 2 pi over 3. Right, 2, 3. 7 pi over 6. Divide by 2. 2. It's going to be 5 pi over 3. And the last one is 13 pi over 6. Some pretty crazy characters we're getting here. All right, it's time to graph. Amplitude is 1. pi over 6, 2 pi 3, 7 pi 6, 5 pi 3. And again, my apologies. You probably want a separate sheet of paper to do all this craziness on. Otherwise, you're going to be shortchanging yourself on space and understanding what's really going on. Okay, my apologies. So we have a positive cosine, right? It's a positive cosine. And amplitude is 1. So they would be, here would be first point, second, third, fourth, fifth, connect them. However, we do have this thingy. So I have to drop all these down by 2, right? 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. Hard to make that. It'll be interesting to note that my asymptotes are now -1 and -3, right? So our max occurs at -1 and our min occurs at -3. It's pretty dramatic. So in this case, our entire graph shifted down into quadrant 4 of this XY graph. So it's all in the negative portion of it. That's the graph though. Problem 4. This like I said, this is deeper stuff, right? This is deep understanding that we're going for mastery here. So problem 4. Consider the graph of f of x equals sine of x. Let's go ahead and remind you what that looks like. Sorry. Starts at 0, goes to pi over 2, pi, 3 pi over 2, 2 pi. It looks like 1, -1, point here. Question to you is, what happens between pi over 2 and 3 pi over 2? What happens in this region right here? Well, we'll notice that what's happening is it's all going downward, right? It's decreasing. It's constantly decreasing. So, remember, recall that compare this to quadrant 1. From here to here would be quadrant 2, quadrant 3, and quadrant 4. So essentially, it would be like us going through half of the circle, right? Going down quadrant 2, going through quadrant 3. And really, it's as simple as this. The graph is decreasing, right? Quote unquote. If you had a slope, which we don't quite have a slope necessarily because it's not linear, it's curved, but it would be almost considered like a negative slope, right? Okay, because it's going down. So the graph is decreasing between pi over 2 and 3 pi over 2. It might be interesting to also note that during this interval, it does have between pi over 2 and 3 pi over 2, there is one max, and there is one min, and there is also one intercept. Okay, right between these two, between this interval. Okay, there is one max, there is one min, and there's also one intercept. That is good to know as well. Part B. The function f of x equals 3 sine 1 half x reaches its maximum value when x has what value in radians? So, if we were to quickly graph this, we know that looking at it quickly, there is no vertical or horizontal shift. It has an amplitude of 3, an amplitude of -3. So we know it's going to have a max at 3, right? The question is a period, right? If this is b, then the period is going to be 2 pi over b. That's 2 pi over 1/2. And I'll let you check, but it'll be 4 pi. So that means I have 0, pi, 2 pi, 3 pi, 4 pi. And if I go ahead and if I were to go and graph this, there's a sine. I get this graph right here. So what the question is asking is, when we hit a max, what is the x value? Okay, because unless if you forgot, the unit circle is made up of coordinates, right? And in this case, this graph is also made of coordinates as well. So when the y value is 3, right? When the max happens right here at 3, right? That's the y value. What is the x value going to be? Pi. Let me ask you this. At what x value is the minimum? Well, the minimum in this case is going to happen at -3, but the y value is 3 pi. Let me ask you another one. At what point, at what x values do we have intercepts? Well, it would be at 0, at 2 pi, and at 4 pi. Okay, so be careful and be aware of that kind of stuff. Next, C. Give the equations for the horizontal asymptotes for this function. So if we were to graph this function, I need more room. Right, well, so this is the 1, 2, 3, 1, 2, 3, blah, just sign. But it's gonna everything's gonna move up by 2, right? So I'm gonna add 2 more of these right here. This one will start here, and this one will start here, and this one will start here, and this one will start here, here. This is what the graph looks like now. Now, what these equations would look like would be f of x equals 5. And this bottom one, let me actually draw it out. Totally missed that. Should be a -1. And then the other one is at -1. Now, there's an easier way to do this. Just look how simple this is. Okay, we know based on this that the max would be 3 and the min would be -3. Originally, right? But then we come along and we take this +2. If I were to just take those max and mins and add 2's to both of them, look what I get. A 5 and a -1. So we did too much work by graphing all this stuff. You do not need to graph all that. You could simply algebraically, and even if you have extra junk in the middle, it doesn't matter. Like if this were a 3 sine, let's be crazy, radical 3 pi over 2.7x minus 84 pi plus 2, plus 2. It doesn't matter what's in the argument. It is as simple as, okay, the max is 3, the min is -3. Let me add 2 to both of those, and bam, I have the asymptotes, right? It will be at 5, and it will be a -1. Okay, so it's a nice trick to know. It's a nice trick to know. Focus on those asymptotes. D. Explain the difference between these two. Well, we know that when we have an added or subtracted term in the argument, what happens is that there is a shift, but it's always the opposite of what you see. So for example, this plus pi means that it would shift to the left, whereas if you have a negative, it would shift to the right. They both have the same amplitudes and the same periods, and they both lack a vertical shift. So this is really a question about horizontal shift. E is actually about vertical shift. You'll notice the arguments are exactly the same. The first function does not have a k value, but the second one does. So what happens is with this one, everything in this function is dropped down by 1, right? Because it's negative. Take a moment to summarize. Identify topics you need to be careful with in graphing and summarize your understanding of those topics. So here's some interesting territory that I'm not going to really require heavily of you, but I do want you to understand the concepts, right? So, so be aware you will be slightly tested on this, but not heavily, extremely. Okay. I do want you to be familiar with this stuff. So recall that the reciprocal identity of cosecant is sine, and the reciprocal trigonometric function of secant is cosine. Okay. And let's see what this is. So what you see before you is a sine graph, right? But I want you to go ahead and graph the cosecant graph. Well, you're going to be pleasantly surprised to see how this works out. I'm going to go ahead and draw some asymptotes, but these are going to be different asymptotes. These are going to be the ones going up and down, because what happens is that, before we drew the asymptotes going left and right, when we reciprocate something, we change the x and y values, we invert it. So these are the inverse. And so the asymptotes no longer will be left and right, they're going to be up and down for example, cosecant. Now recall that cosecant is the reciprocal of sine. And what this means for us is the following. That the graph of cosecant is going to go ahead and let me be more careful with this. I'm going to also draw these as well to kind of guide us. Intense. Okay. This is what cosecant looks like. Let's see if I can do this right. I missed. Nabbit. So these red ones are the graphs of cosecant. So, we would keep going and going and going, right? And it would actually hit at 1, sorry. And this would hit at -1. Note, etc. Okay. So this is cosecant. What you need to be aware of, however, is that these are going up forever. They're arrows. And they will never hit this pi value or this 0 value or the 2 pi value. Okay. So we're going to talk about this a lot more in great detail next semester in pre-calculus when we talk about limits. Okay. I just want to kind of spiral that in. However, be aware that these are asymptotes, and unlike this one where it actually does touch, right? This actually has a value of 1. This actually has a value of -1. These arrows going upward in both directions, they go to infinity, positive infinity. They never actually touch these asymptotes that are going up and down. Same thing with the ones down here. These go to negative infinity. Okay, that's cosecant though. Not bad. Which means you could probably, if you want to go ahead and take a moment to pause me, you could probably pause me and you could probably figure out what the graphs for secant would look like based on secant based on cosecant. I would suggest, however, maybe finishing this off and then dropping these like that. Okay, we drop the asymptotes where it hits it at the axis. So you're gonna pause me. Go ahead. See if we can figure this one out. And you probably did, right? You probably have something that's right here. Same idea. Right here, same idea. Right here, same idea. Right, I totally missed that one again. Same explanation. It's the reciprocal of cosine, so we take the cosine, we just piggyback off of it, and that's the end. I would expect you to be able to do these for any graph, so I may have you do a couple of secant and cosecant ones just to prove to me you know what's going on. Nothing too awfully crazy. As long as you can graph on a cosine, you should be able to graph these perfectly well. Okay? Though I will not require you to graph tangent on your own, I do want you to kind of observe how this is formed. So recall that tangent is the ratio of sine over cosine, right? So in this case, we have the green represents sine, right? And so you have the green graph that represents sine. And then you have the blue, which represents cosine, and that's the blue one right here. And then the gray one would be the ratio, right? So that's sine over cosine. So if we were to go ahead and take these numbers and move up, right? The green is a sine value, the blue is a cosine. You'll notice that as we progress through the angles, that the y value, the sine value gets larger and the cosine gets smaller. You'll notice that the tangent value is increasing. However, as we get closer and closer to 90 degrees, you'll notice that it actually starts to explode. And it climbs very quickly. If we were to go more specifically like 88.1, 88.2, you'll notice that these numbers are just exploding really fast. Okay, so at tangent of we get this right here. That is true because you have 1 over, oops, sorry about that. That's true because you have 1 over 0, right? And that's undefined. Now, when you look at your graph, this is represented by the gray. These gray lines are going up like that, those spaghetti strings. And what happens is that we actually have an asymptote right here that cannot be touched. It does not approach. We have an asymptote right here as well at 270 and so forth. Okay. And so what will happen as I continue this graph through the unit circle, you'll notice that as I go 91 degrees or 92 degrees, it starts with a negative value. And they keep climbing and they keep climbing. Remember, keep track of this, keep track of these numbers right here. Then we get to a point where the ratio of these two is going to give you 0. And that corresponds to this point right here, right? It's going to go ahead and start climbing up as these numbers increase. And you see it's climbing up. This is a very difficult graph to figure out tangent. Recall that in as far as the quadrants are concerned, in quadrant 1, tangent is positive. In quadrant 2, it's negative. In quadrant 3, it's positive, right? In quadrant 4, it's negative. So you have that going on right here. Here's quadrant 1 from 0 to 90. You'll notice that tangent was positive. In quadrant 2, it was negative. In quadrant 3, I gotta change colors. In quadrant 3, it was positive, right? When reference to this up here, above is positive, below is negative. In quadrant 4, you'll notice it's negative. Okay, so just wanted to let you know, this is a more tricky graph to be aware of. I just want you to be aware that it exists, what it looks like, that they're asymptotes. It will never approach these, it will never touch them. For your summary, explain the process for graphing any sine or cosine graph.